The agent's shell problem. The agent's shell problem. Adversa.ai just published a systematic audit of AI coding agent shell guards, and the results should make you reconsider every tool in your stack. Their GuardFall research tested 11 open-source agents, including Cursor, Windsurf, Klein, and Aider, against 5 classes of shell injection bypass, tilt stripping, IFS variable expansion, command substitution via backticks, base 64 encoded payloads piped to bash, and destructive argv flags like .exec. Every single agent fell to at least one class. Most fell to all 5. The quote stripping bypass alone is embarrassing. Agents that sanitize input by removing quotes actually create injection opportunities that didn't exist in the original string. The only tool with a structurally sound defense was Continue, whose 5-stage tokenize and canonicalize evaluator parses commands into an ASD before matching against policy, rather than pattern matching raw strings like everyone else. The timing is notable. A new paper, Arxiv 2606.24496, reports the first security analysis of 12 offensive security agent tools, the red team agents themselves. The researchers achieve near-deterministic remote code execution on systems powered by Claude Opus 4.8, GPT 5.5, and Gemini 3.1 Pro, without using prompt injection at all. The kill chain is elegant and terrifying. Worker RCE leads to privilege escalation, then persistence, sandbox escape, and full host compromise. 10 of 12 tools were vulnerable. The attack works because these agents hold shell execution privileges by design and trust their own tool outputs as authoritative context. When an attacker controls what the tool observes, a malicious scan target, a crafted network response, the agent faithfully executes whatever the poisoned context implies. No jailbreak needed. The architecture is the vulnerability. This is the structural problem this newsletter has been circling for a year. LLMs process tokens without distinguishing trusted instructions from attacker-controlled data. And when those tokens map to exec, the blast radius is the entire host. A Reddit thread on LLM backdoors crystallizes the community's current defense posture. A poisoned model that can only emit text is mostly harmless. The whole risk lives at the agent boundary. Tool calls, code execution, file access, network. Open weights don't protect you from a trigger you can't enumerate. Closed weights don't protect you from a provider who can silently swap the model. The defense ends up the same for both. Treat the model as untrusted by default, require human confirmation for consequential actions, watch aggress, and never wire it directly into anything destructive. Build the loop, not the agent. Build the loop, not the agent. Reuven Cohen's meta-harness crossed 100,000 NPM downloads in its first 2 weeks. The pitch is blunt. Calling an LLM is easy. Making agents reliable, governable, repeatable, measurable, and cheap is the hard part. Meta-harness generates repo-specific agent harnesses that wrap the model with task rules, tool policies, scoring, receipts, routing, verifiers, and promotion gates. Every run creates evidence. Every failure becomes training signal for the harness itself. Every improvement must survive tests, cost checks, and safety gates before promotion. The framework supports Claude Code, OpenAI Codex, GitHub Copilot, and several other execution surfaces because, as Cohen puts it, models are replaceable, harnesses compound. Forge Quality's Loop Came Home article provides the deep technical complement to Cohen's manifesto. Where meta-harness evangelizes the thesis, Forge Quality traces the engineering. How the run, measure, learn, mutate, verify, promote cycle actually works in production. What breaks when you skip the verify step, and why that verify step is the one enterprises will actually interrogate. If it can't catch a regression before a customer does, the rest of the flywheel is theater. This is the argument we've been building toward over 10 months of covering harness-first architectures. The loop is not a framework feature. The loop is the product. 2 technical gists from the Rooflow project show what this looks like in concrete implementation. Version 3.24. 0 introduces a self-learning retrieval configuration flywheel. The system measures retrieval quality, mutates config parameters, and promotes improvements through ED 25,519 sign gates. Cryptographic proof that a config change was tested and verified before deployment, not just checked in by whoever had commit access. Version 3.25. 0 adds a WASM embedder tier intended to push simple transforms below the LLM entirely. Sub-millisecond, zero-cost operations like variable renaming or type annotation that don't need a model at all. The revealing detail. The lattice WASP package referenced in the architecture doesn't actually exist on NPM yet. It's a dead letter seam that degrades gracefully to the next tier when the import fails. The architecture is ready. The package is a bet on the direction. That's harness thinking. Build the slot, prove the fallback, ship the package when it exists. Code Cleanliness and the Agent's Bill. Code Cleanliness and the Agent's Bill A Controlled Minimal Pair Study, Arxiv 2605.20049 delivers the first rigorous evidence that code cleanliness directly affects what AI coding agents cost to operate. The researchers introduced and removed SonarQube violations, Dead stores, unused imports, overly complex methods. To create matched clean/dirty versions of identical codebases, then ran Claude Code with Sonnet 4.6 against both. The headline result is counterintuitive at first glance. Cleaner code does not change pass rates. The agents solve the same problems either way. What changes is the bill. Clean code reduces token consumption by 7 to 8% and file revisitations by 34%. The agent spends less time rereading files it already visited, less time parsing through messy structure to locate the edit point. The implication is practical, at scale, across thousands of daily agent runs. That 7 to 8% token reduction is real money. And the 34% reduction in file revisits means faster wall clock completion too. Technical debt has always had a cost. Now there's a number on it. The cost story connects to the tool story. Apple shipped an official Safari MCP server this week, giving AI coding agents direct access to Safari DevTools. Console logs, network requests, DOM inspection, accessibility audits. Through the Model Context Protocol. This is significant not for what it does. Browser debugging is not new, but for who shipped it and what it implies. When Apple builds first-party MCP infrastructure, agent-driven development tooling has crossed from experiment to platform investment. Better tools mean fewer wasted tokens. An agent that can read a live console error directly doesn't need to infer the bug from source code alone, doesn't need to add logging, rebuild, and recheck. Every round trip you eliminate is tokens saved. Frontier models on Consumer Iron. Frontier models on Consumer Iron. The local inference community had a productive week. A follow-up benchmarking post for GLM 5.2 running NVFP4 quantization on 4 NVIDIA DGX Sparks reports 24 tokens per second at 128K context. After the author tracked down and fixed a LLM MTP multi-token prediction draft parallel configuration bug that was silently throttling throughput. The DGX Spark is NVIDIA's $3,999 personal AI workstation with 128 GB unified memory. 4 of them networked is not cheap, but it's a fundamentally different category than a data center rack, and 24 TOC/S at 128K context on a 30B plus parameter model is workable for real interactive use. The key engineering lesson, LLM's MTP configuration was wrong out of the box. The hardware was capable, the software was misconfigured. How many other local setups are leaving performance on the table because of default configs? The more provocative result comes from DeepSeek V4 Flash running on 2 RTX PRO 6000 GPUs under LLM. In a rigorous indie coding benchmark with full datasheets published, it finishes real coding tasks in about 2 minutes. Roughly 3 times faster than Sonnet 4.6 through the API, which averaged 6 minutes per task. Quality lands around Sonnet level. Opus and Fable still win on raw diff quality by a clear margin. But when the question is, what do you actually get when each model is set up the way people really run it, local DeepSeek is competitive on quality and dominant on speed. The critical engineering detail, sparse attention in DeepSeek's MOE architecture, is what preserves quality at this throughput. Dense attention at this parameter count would be both slower and worse. The July 2026 local VLM landscape shows similar maturation. Vision language models that were research curiosities a year ago now run comfortably on consumer hardware with results good enough for production integration, not just demos. At the extreme quantization frontier, PrismML's 1-bit Bonsai 8B achieves 92% tool calling accuracy using grammar-constrained decoding. 1 bit per weight. The tool calling result is the significant number. Tool calling is the weak link in local model deployment. You can run inference fast on quantized weights, but if the model can't reliably format a JSON function call, it's useless inside an agent harness. Grammar-constrained decoding forces valid structure, and at 92% accuracy, Bonsai 8B is approaching the threshold where 1-bit models become viable agent workers. And then there's NASA's CMODA project, testing Ramalama and Llama.c, PP for a crew medical officer digital assistant that runs entirely on disconnected hardware during deep space missions. No internet, no API fallback, no second opinion. If your local inference stack has to work or people might die, deep space is the acceptance test. Inference innovation. Inference innovation 3 pieces this week attack inference from different layers of the stack. A new Llama.c PP sampler called particle scattering uses rank space Gaussian diffusion to reshape the token probability distribution during generation. The core idea: flatten the head of the distribution so the model explores more diverse continuations, without leaking probability mass into the deep tail where incoherent tokens live. Standard temperature scaling can't separate these two effects. Raising temperature flattens the head but also promotes garbage from the tail. Particle scattering operates in rank space rather than probability space, which decouples head flattening from tail leaking. The result is more diverse, more creative generation without the quality collapse you get from naive temperature tuning. For anyone running local models, this is a drop-in sampler that changes output quality without touching the weights. NVIDIA open-source SwitchYard, an LLM proxy that translates between the OpenAI and Anthropic API protocols and routes requests to the appropriate backend based on configurable rules. Think of it as an Unix for LLM APIs. Protocol normalization, smart routing, and a single entry point for multi-provider deployments. It's plumbing, not glamorous. But plumbing is exactly what makes multi-model agent architectures actually deployable in production rather than demoware. MiserFlow achieves 1025x speedup for diffusion image generation using training-free multi-resolution flow matching. No model retraining, no distillation, no architecture changes. It accelerates existing diffusion models by restructuring how the denoising trajectory is computed across resolutions. Start coarse, refine progressively. Skip redundant computation at high resolution where the structure is already determined by the low-resolution pass. Gatekeepers and trust. Gatekeepers and trust. Google now requires every Android developer to register through a centralized identity verification program by September 2026. The stated reason is malware protection. F-Droid's analysis cuts deeper. This is a gatekeeping operation that threatens independent software distribution for 4 billion devices. F-Droid has been distributing open-source Android apps for over a decade through reproducible builds and signed repositories. A trust model based on cryptographic verification rather than corporate identity checks. Under the new regime, developers who distribute outside Google Play must still comply with verification requirements designed for commercial app stores, or lose access to Google Play Services APIs that most apps depend on. The protection framing follows a pattern this newsletter has tracked across multiple domains. Create or highlight a real security problem, solve it with centralized control, and collect the power to decide who gets to ship software as a side effect. The same trust as control dynamic surfaced on this week's All In podcast, where the panel covered 3 stories with a common thread. Anthropic's Fable 5 became the first AI model subjected to U.S. government export controls after jailbreak reports and unauthorized sharing with SK Telecom triggered a temporary restriction. Later resolved, but the precedent is set. Cursor's $60 billion acquisition values an AI code editor higher than most of the companies whose code it helps write. SpaceX raised $85 billion at a roughly $2 trillion implied market cap, making it the most valuable private-to-public transition in history. The through line across all 3: who controls access to the tools that matter? And what happens when that control concentrates into fewer hands? 0 days, scam bots, and embedded AI. 0 days, scam bots, and embedded AI. The Rogue Planet Windows Defender exploit demonstrates a TOCTOU time of check, time of use race condition in the real-time scan and quarantine pipeline. The attack uses NTFS junction points and opportunistic locks to redirect Defender's quarantine operation. The scanner checks a benign file. The attacker swaps the file system target between check and action using an oplock callback, and Defender's elevated privileges quarantine or overwrite an arbitrary system file. It's privilege escalation through the security software itself. The deeper irony being that Defender's real-time scanning requires elevated file system access by design, and that elevated access becomes the attack surface when the timing window between check and action isn't atomic. This is the same class of bug TOCTOU that keeps appearing in security-critical code because making file system operations truly atomic on NTFS is genuinely hard. On the social engineering front, a video demonstration shows how AI-powered phone bots deployed by scammers can be turned against their operators. The bots follow instructions faithfully. That's their design purpose. And that instruction-following fidelity becomes the vulnerability. When you understand the prompt structure driving the bot, you can redirect it to waste the scammer's time and resources, extract the underlying script, or simply keep the line occupied so it can't dial the next victim. It's a small-scale, oddly satisfying application of the same principle from the agent security section. The model does whatever its context tells it to do, and whoever controls context controls the outcome. A 10-level Arduino AI coding progression maps the maturity curve from vibe coding. Paste a prompt into ChatGPT, flash whatever comes back, hope it compiles. Through structured agent-assisted development all the way to full ESP. IDF. Work where the developer understands the register-level hardware interface and uses the AI to accelerate implementation rather than replace understanding. The framework is useful well beyond Arduino. It's a general model for how AI-assisted development should mature in any domain. Level 1 is the AI writes it and I hope it works. Level 10 is I understand the hardware. The AI accelerates what I already know how to do, and I can verify its output against the datasheet. The gap between those 2 levels is where most of the embedded AI development community currently lives, and closing it is the actual work.